So, hello everybody. Um, so today I've also added a bunch of stuff to Canvas. Anybody had the time to go and check it out? So, wondering if we share files through here. I'm not sure. Want to drop a file here? No.
I think everybody but Hannah and Jorge don't have access yet to Canvas. We need to give them access through Georgia Tech.
But through the app you can share files, but here you can't. So let me see. Only you can create.
If it's just what's on under files for today,
Mhm.
well, I don't think I have everybody's email address, but maybe Flavio can just email to Hannah and Jorge. I think everybody else
Yeah,
is on here. Is anybody else not on here on the course?
I'm
Is that
not
okay,
sure.
Flavio?
Yeah, I'm trying to log into Canvas. I haven't.
I already, I think when I emailed Niels, probably you were on the CC list. Forward that email. Uh, Email also didn't leave. I don't know. I am having computer issues on this side.
Yeah. Let Flavio worry about emailing them, and
Yeah, I'm
you can
gonna
just.
email this thing. I'll get in it now.
Thanks.
And bring it here. Okay, so probably we're okay with.
Yeah, we
Okay,
lost him. Oh,
okay.
he's back.
Do you still have me?
You are
Yes.
back.
Yeah.
Okay, good. Mhm. So what we talked about yesterday was we talked about the vertex shader and the fragment shader. And we talked about the fact that if we had a physical world that the objects existed in that, we would have something called the clip that the x, y, and z that would be plotted would be all in the range -1 and 1. And in order to do that, whatever coordinates you had in the physical world that you wanted to project into the screen, you had to you had to construct triangles somehow. And in order to construct triangles to draw them on the screen, you would connect vertices. You start with vertices and then connect them with lines. So if you had a triangle like so in the physical world and you wanted to take it into the clip space that would later on project it on the screen, all you had to do was to find out where would be the location of the vertices in the clip space. As soon as you found out the location of the vertices, you would be able to connect them to form the triangles and then color that triangle so that your geometry is fully colored. So the part of the shader that was in charge, the GPU program that was in charge of taking these vertices from the physical world into the clip space to later on be projected on the screen, was done by the vertex shader, which we showed a couple of the uh, common vertex shaders, and we talked about this fact that the vertex shader, in addition to doing this transformation from the physical world into that, is able to do interpolations for us. So we would be able to calculate what is the coordinate, for example, for each fragment that we want to later on color on the screen. So what we generated in our default vertex shader, we calculated a value called pixel position, POS, and CC or CC basically, that they could come into the fragment shader that we later on use for coloring, so that we can use it to find out what is the coordinate of each of these pixels and fragments. So we ended up with showing just a rectangle and projecting it directly to the screen as a default geometry that we are going to work with, that had 0 and 0 coordinate here and 1 and 1 coordinate in that corner, and that would match exactly what our canvas would be displaying on the screen. So this is where we left off. And then you could have for example, CC number on each of these guys, CC, the CCX and CC.Y would basically represent the X and Y coordinates that was between 0 and 1 for those pixels. Now, today, before we start, I want to talk a little bit in more detail of what's going to happen in GPU, because I've noticed that a lot of times these students or the people who are trying to use WebGL, they struggle with this concept that everything is happening in parallel. That certain coloring is happening, and they are still living in the notion that everything is happening in serial. So what we talked about in the fragment shader part was that we said if we wanted to color this geometry would be broken into multiple pixels, or what we call as fragments. And if you wanted to color this rectangle on CPU, what you would do is you would probably start from one of these corners, maybe here, color this pixel, then move to that pixel, color that one, and then go to the next one, until everything is colored. But that's a serial task, and it would take a while if the picture and the image is too large. So what the GPUs were designed for was that usually when you are manipulating images, what's happening to one pixel, it can be completely independent of the neighboring pixels. So you could technically start analyzing what would happen for these colors in parallel and launching a bunch of workers to color all of these pixels at once. So, for example, if you had, I don't know, 1,000 workers, you could decide that I want to color this 1,000 pixels at once, and then move to the next 1,000 and next 1,000 and next 1,000 until everything is. So what the fragment shader is actually doing is the recipe for all of these cores to work in parallel with each other. How the work is distributed between these ones, you don't have to worry too much about that. But this notion should be in your mind that everything is happening in parallel, and each core technically, until the computations are finished, is not aware of what's happening to the neighbor. It might have some information about the previous ones, but while calculations are happening, unless you implemented something explicitly, it has no information about what's happening to the neighbor. Everything is happening independent of the other guys there. Okay. So having that in mind, we can start implementing a couple of examples here. If we go to unzip the files, there are a bunch of cheat sheets and everything is already implemented so that you don't have to worry about this. Up this.
So, Hannah, Jorge, you got the email? Okay, good.
Yep.
And there is this cheat sheet sections that everything is already implemented that you can go through. So, okay. So we stopped somewhere with the drawing the circle yesterday, right? Is font large enough for everybody to see?
Yeah.
Yes?
Yes, thanks.
So we removed the default geometry so that we are now drawing just a rectangle. We removed the vertex shader because there is a vertex shader already implemented, and we are going to concentrate our work to this part that we are just going to work with the fragment shader. Speaking a little bit, looking at what I'm going to talk about. Okay, so what we are going to talk about is start changing this code. We were, if you run that right now, go back to where that you should be getting this circle. So if we were inside this distance, we were plotting something. We were plotting a red color that would change gradually based on the coordinate x. You could just make it 1 so that everything is just simply red. Or you could change it to any color, other color, and if we are outside, we would be coloring something else. The next thing we want to do is we want to start defining new variables. We will start with this simple scenario that we define a new vector to type z0 times 4 2 2 2. Okay, the reason that I'm doing this part is that I want to be able to implement the random draw set and write again this. Okay, so formulation for the Mandelbrot set, if we have a complex number on the complex plane, if we square that complex coordinate and we add the initial coordinate and we get a new one, and we repeat this process forever, if the modulus of these numbers are bound, then we say the point is part of the set. If the modulus is not bound, then we say the points are not part of the set. So for this complex calculations to be carried out, I believe most of you are familiar with complex numbers. So what we are doing right now is that we are creating part of the complex plane that starts from, remember that this is between 0 and 1, so if you multiply it by 4, it becomes between 0 and 4. If I subtract 3 from it, then the range of x would be from -1 and between -3 and 1, and the y coordinate or the imaginary part will be between -2 and 2. So for the loop, you can start introducing new variables and you will see that it is very C-like. So I is less than 1,000 times. You can add one counter to that. So you're looping over something. And inside the loop, we want to calculate z squared, and the new real part for this would be the real part squared minus the imaginary part squared. And the imaginary part would be 2 times the real part times the imaginary part. And to this entire thing, we want to add z naught. Remember, this was the formulation for the math. So we started from the original location and we are squaring whatever we have, and then we are going there. We are adding the original coordinate. So to check whether the modulus is going to go to infinity, there is a theorem that says that at any point, if the modulus of the z is greater than 2, then the point will never be part of the set. So we can say that if length of z is greater than 2, we want to break the loop, or we can say we want to actually calculate the output color and say that these points are not part of the set. So we draw it as black and we return. If we manage to finish the loop and not return, it means that this modulus remained bound in all these iterations. So we can calculate a new color that is, let's say, white. And white would be all numbers equal to 1.
A question?
Sure.
What's the modulus?
The modulus is the length of the vector, basically. So it's the real part is the square root of the real part squared plus the imaginary part squared.
Oh, gotcha. Thank you.
You're welcome. So this length function is actually correct.
So, but now you're plotting, and it's plotting in a different size. Before you were plotting between 0 and 1, right, or -1 and 1.
Huh?
and now it just plots.
It's
So
still
how
plotting
did it
between
went? How
0
did it
and
went?
1. So it's still what is in charge of mapping that rectangle is our vertex shader. And once we set that vertex shader and we got rid of it, it's always going to map over the entire screen. Now,
But
what we are defining is that we are saying that we have an auxiliary variable there that for each of these pixels, we are assigning a new coordinate system basically to that one. And this is just for our calculations. The GPU is not aware of these transformations that we're
right,
doing.
but you deleted the lines below that they were before to plot on the screen. So I don't. Now there's nothing to plot. So I'm that's why I'm confused.
What parts did I delete?
So you deleted when you were plotting the circle, um, the
We were
circle and the
calculating a
square.
color, right? So it doesn't matter what we have here. So
Oh, that was
all
the
we have
color.
to
I
do,
see. I see.
sorry, what we had here. So let me comment out this part so that we
Ah,
make it
that's
clear.
right. It was just a color. I see. I see.
It's just we are calculating a color for the pixel. So here we have just a recipe that says what is the color for the pixel. So I can say the color is just red, regardless of what is the coordinate. So what we
Right.
will have is that we are going to have a red rectangle, right? Where in this scenario, going to be
Right.
red.
Okay.
Here now we are defining some auxiliary variables based on these coordinates that we have passed from the vertex shader, and we are deciding what color we are going to assign to each pixel.
Hmm.
So basically now we have changed this output color. We are deciding what we are going to do with the colors here in the loop, right? Does that answer your question?
Yeah.
I have a potentially dumb question. I did like a very small amount of JavaScript a while ago, so I'm trying to pick that back up as we go. Are the decimals after all of your literals when you're assigning things like CC times 4 dot? Is that just does JavaScript refuse to treat integer literals like they're floats? Do you need that to tell it, hey, this is actually float?
Okay, so one more round, I want to emphasize that this part that we are in the shader, the language is called, this is not a JavaScript part. So this is
Oh,
a
okay.
language of GLSL. This is the shader language programming. So this is GLSL 3. Okay. And this version that you saw here, these are the things that I didn't go into detail. This version line that starts with a hashtag is compulsory, and it should not be preceded by any other character. So it should be the first line and the first character that it starts. And this version 300 ES is ES is short for extended systems, something like that. So it's for basically browsers and stuff like that, and cell phones and things like that. Because the GLSL language is used generally for all graphics cards. ES part is just for it's a smaller portion of that has a lot of restrictions compared to the general GLSL language. So this part, one important feature that you notice that I'm doing. So in the JavaScript part, which is in this script section that we are defining the renderer and we are passing the shaders and stuff, you can mix and match types. You can say that A was 2, and then say A was 2 plus 1.1, and JavaScript would not complain about that. So this part is in JavaScript, and you see that I've seen main script. I want to emphasize that this is in JavaScript. The shader language is in GLSL. In this part, you cannot mix types. So if I type 4 here, and let's open the debugger here. It gets very sad immediately and angry, and it starts yelling at you at line 14 of your shader. Line 14 says wrong operand types, no operation multiply exists that takes a left-hand operand of type high precision 2-component vector of float and a right-hand operand of constant integer. So basically you can't mix floats and integers ever. If I had another variable here, let's say I had a variable named int4 that was defined as 4, like so, and I wanted to multiply 4 there, I would still get the same error because I couldn't mix types. And if I insisted on doing that, I had to do a conversion here, say that cast this one as a float. So a type conversion happens in place, and then it becomes happy and starts doing.
Just for those who were not here last class, to see the debugger in the front, just do F12, and then the debugger will show up.
Yeah.
Also, just as a side note, JavaScript actually doesn't have integer types. All numbers in JavaScript are floats.
Technically, before you cast them as float, they are stored as integers. Actually, they are stored as integers. The moment that you you add or multiply a float with them, or you put them into any variable that there is somewhere a float existing there, immediately it does a type conversion and it casts into float. So there is an implied type conversion that happens there. So you can try to do that. You can try to define a variable, add a 0.1 to a variable and subtract to that and try to add numbers to it, and you will see that the errors will start growing, and then if you print it, you will see. Also, everything is in the JavaScript section. Once you define something as float, it's a double precision float. It's not a single precision float, but it is possible to define variables that are single precision as well as half precision. You have to explicitly define them. And they can be only of type arrays, those specific types. But there are integers, and integers and booleans are both of the same type. So you can define a variable as false. And then you can multiply a by 100, and it will assume that a is 0. And if you define a as true, it will assume that it's 1. So there is a very subtle underlying type. It also depends on the browser implementation. Chrome and Firefox, they start with an integer if you assign an integer, and then they have an implied casting if you mix them with floats. But thank you, Max.
Yeah, no problem. It's come up for me a lot.
Yeah. All right. So most of the errors that happen is because this, if you're implementing a program, most of the errors are because you forget to put a dot somewhere, unless there is a casting and you're doing multiplications or additions or something like that, it will get very sad. Also, so is the comparison operators. So you can't compare floats and integers with each other unless you cast them first by saying that this convert this to a float, and then it will become happy and it will start doing that. Okay. Any other questions here? No? Okay. So one other thing that you can do is defining macros. So to define macros, plain border macros, T square. If you have something like this that appears somewhere in your code and you want to treat this square as a function, one way is to define it as a macro. So whenever it sees a C square and you pass something as Z to it, it would try to replace it by this. So your code becomes a little bit nicer. So C square as Z plus Z naught. This version now becomes does the identify.
Does the float cast need to be high precision for this to work, or does the precision not matter when you're doing the typecast?
The precision, first of all, if you define any float or anything and you haven't defined the precision, it gets sad. So it starts complaining. So you need to actually do the definitions first.
Okay, so you can only have like one level of precision for the entire shader.
Yes.
You need a column there, right? Don't you need a column at the end?
No.
Line 30? No?
No. Fine. Trying to see why. Usually shouldn't be getting upset yet.
Yeah, I mean, I did exactly what you did. I just copied it into my macro and mine works. I don't know what's going on.
Same here, yeah, it worked for me.
No. Type defining correctly. Define. Place it right there. Shouldn't be complaining, but it's complaining.
Yes,
They did. There is nothing there anymore.
Oh wait, you're doing it outside the for loop, that's why. Z is
It should be fine because Nothing is defined yet there, and it shouldn't be defined. It can be technically anything, so you can be defining square complex square of z. It can be returning just z. Should be fine. Shouldn't be complaining about anything. And vec2 zx dot zx. But these are the things that always work. Sometimes they stop working. I don't know.
Yeah.
Today is not my day. Best
Don't buy a lottery today.
best the blue jean was not working now. Shouldn't be complaining. Yeah, it doesn't complain now. Should be able to. Okay, now it's working. Exactly the same thing. I don't know why it didn't work first time. Okay, so what the macros do is, if you have something like this and it's going to repeat a lot in your code, it helps if you define it as macros rather than functions. And the reason for that is that when you're defining a macro, what will happen if you're familiar with C programming, what macros do is actually these are replaced whenever a C square of something is seen by the compiler. In the preprocessor section, it will be replaced by this expression that is over there. So whatever is inside the bracket would be replaced there, and it's as if you typed it right there. Whereas if you define the function of a square, then it will create a branch that first you have to go inside that function, then probably auxiliary values are generated there. Usually the functions in GLSL are passed by value. So the variable z itself is not passed. A copy of it is passed to the function, and then the calculations are done, and then the value is returned. And this branching usually slows down the code. So if you do it like this, it's as if you typed it, and it doesn't create any overhead to the program itself. But what you need to be careful is that something like this won't work, whereas it should definitely work, because if you are saying z plus 1 in other locations, let's just leave it as it is. If I'm doing it like that, I get the Mandelbrot set, and if I add a 1 to that, I should be able to do this stuff, because the compiler is very happy about that. It has no problem with it. The set is just disappeared. And the reason is that then it will start to add an element-wise 1 to everything. But if I'm adding a 1 here, right now, this section, what you will see that it says that field selection requires a structure. And the reason is that now z, which now is passed as z plus 1, is going to be replaced as z plus 1 with a dot over there, and then the x field of that would try to be accessed. So it's just like z plus 1 dot, and then dot x. And obviously 1 doesn't have an x field, so you won't be able to access that part. In order to fix these problems, you should be very careful when you're passing stuff here, so you can just pass those ones inside brackets. And what will happen is that then the entire thing would be calculated before they are passed here. This guy. So it becomes save, and you should be able to carry out that operation now. So when you're defining macros, you should be careful about these stuff. It creates this ugly set. Okay. Now, one other thing that probably I want to go through, we're almost out of time, is defining functions. So I put an example for defining the function as well. We can have a vector2 complex square that gets a vector2 type input x, or you can say a, and return vector2 type a dot x times a dot x, a dot x times a dot x minus a dot y times a dot y, and times a dot x dot a dot y. Now, if you replace this one, c squared, with this complex square function that we wrote, we'll calculate that, but you will notice that you can add stuff to this part here that we couldn't do initially for the macro, and the reason is that now we are able to pass actually the value here. So what's passed into the function is not the variable a itself, but the value that is passed here into the brackets. So automatically you can have anything that is coming here as an input. This is nice if your function is going to return just one value. What if you wanted to calculate multiple values? For example, if I wanted to calculate the complex number, as well as probably the modulus of the number, the new number that I calculated. So if you want to have multiple values outputted, you can have a keyword here that is called out that can output a new variable. Let's say I want to calculate a float number, L, and that L is length of A. Okay. And I could have a float here, L, that I can pass to this function now. And not only this one returns a value here, it also has other variables it can be passed as the output there. So now it gets that L, and set this one back to there, getting that value. Now instead of calculating the length here, I can pass the L over there. It's a little bit different logically, but the result is almost the same. Okay, so now you see that the function is returning multiple values. So in order to design functions, sometimes it is necessary to design functions if you are converting one of those models From an old code, you may see that the programmer or developer of the old code, that could be a Fortran code, or I don't know, a C code or a MATLAB code, designed it in a way that it receives just a bunch of variables as input, and then it has multiple outputs. Otherwise, either you have to unroll the function and just take it out and see what's happening, and then streamline it in some sort of sense to something else, or you can start using this feature with the out keyword to output multiple values out of a function.
Can you send data in through L? Like, can the function do operations on L?
Um, I I don't think so. We can try to do that. We can say L is times L.
In this case, it probably shouldn't work since L isn't initialized, but I don't know how WebGL handles that.
It takes it as 0.
Oh, okay.
It takes it as 0, and it um, should remain inside. So, no, I remember that you can do it like this. If you want to have something as both input and output, you can have another float here, and you could say Li, and then you could multiply by that as Li, and you could pass L twice there, one as input and then the other one as the output.
So this isn't implemented as like reference or pointer passing. It's something else.
It's something else, yes.
Okay.
It explicitly calculates the value, as I understand it from the limited sources that are online, is that basically a new variable is defined inside the function with the limited scope that is there. It's defined, and whatever value is in the end inside it, the value is copied to the output value that is over there. So it's not really a pointer, and there is no notion of pointers in the GLSL part.
Okay.
Can I just want to make sure I understand. Before we had this function defined, we were doing the if length of z is greater than float 2 after we had set z equal to the complex square plus z naught. And now
Yes.
we're taking L as length of A, which is before we do that calculation. Is
Yes,
that
so it's a slightly different. It's just I'm showing that the function can be implemented like that.
right? But isn't that a different comparison now? Isn't that effectively checking if the last z in the loop when you're doing the if? I mean, it would still work because you're just doing the iteration up to 1,000,
Yeah,
but that's
It is.
not the same effect, right?
Yes, yes. Technically, it's not the same effect. It's
Okay.
just the getting the skill to implement the function. That's the only point that I'm
yeah.
Okay. Yep.
You will run it 2001, right? And then you get the same results.
making.
But yeah, that's a good point, Darby.
That's a good point.
I mean, it will not affect this one, but yeah, you're trying to compare other things. Yeah, yeah, you have to compare exactly the codes at the right time, right? Yeah.
Yes, yes, exactly. Happy with that right now, but not drawing anything. Everything is part of the set now. Okay, what else? I was planning actually today to talk about textures and outputting to
You could
texture.
before you go that I was in the outcode color. You can also put the value of L, right? In Vec 4,
Yes,
you can put maybe L, and they will give you a little different colors.
yes, yes. So when I go to textures, I actually start doing that part.
Okay.
So let's make this one a little bit. Usually the value of L is not used. Logarithm of L is used because when it blows significantly. So usually if you want to do that, you should have log of L, and log of L is more appropriate sometimes. Some sort of a coloring. It's a little bit nicer. Yeah. All right. So you could change this one a little bit, like for example the range that you're plotting. So you could multiply this one by 4. Make it symmetric there, and instead of we have z0, then we could change z0 to something else. Let me see, what is it? Vec2 of 1 and 0.8. Let me just make it as 1 here for the moment. What was the number? 0.8?
It didn't work with 0.8, no. There you go.
This is just a little bit different, where we are using the square. Minus 0.9 actually gives you minus 0.9. Inside.
Yeah, but you want to do it on the inside, right? Not the outside. You want to do the other one, right? The outside.
Yeah, the outside actually needs to be colored properly if you want to plot it with the color of those things. So if you want to make it here, this should be log of L and 0 and 0. Here L.
It's been one parenthesis.
Thanks.
Oops.
That's the inside one. It's actually here. The correct one is to be here, and then this one should be outside because that's the part that is actually we are going.
That's the one that you change it. Yeah, the other one that changed very little. Yeah.
The other one is inside, and the colorings. And usually, there is a, if you want to get a proper coloring there, there is a division by, what usually happens is that here it is the iteration number that you have, the coloring schemes that people usually use, and here there is a log of 2. Yeah. Everything divided by 100 probably. a better coloring. I can play with those numbers and then it becomes nicer. But in the next session, when I start to plot into textures and I start using the coloring algorithms that we have for plotting calculated values, using some color maps that are already inside the library, you will see that you can get much better results with plotting. But I think I will stop here today. We couldn't make too much progress today because of the technical difficulties.
No, but I think it was good to see the macros and just
Don't we have 20
calculating
more
something
minutes?
else. It was good.
Yes?
Doesn't it go till 4:30?
No, it was from 3 to 4, right? We scheduled it from 3 to 4. We started
With plus minus a little bit extra line just in case.
I think the blue jeans goes to 4:30, but
the Blue Jeans, I think, goes for half an hour in case that there is questions.
Ah, okay. Yes.
All right, Abusar, thank you so much. Anybody else has a question for Abusar?
I guess one question I had is it like the same as the C preprocessor for OpenGL? Like, can you do like concatenation and all that stuff too?
You can do a little bit. It's very similar to that. I haven't tried to do a lot of concatenations, but you can try to see most of them. It's very verbose about its problem. So the moment that you do something that is not happy about it, will immediately start complaining about it. So,
Okay, so it's a different syntax from the C preprocessor, even though it looks the same example.
very similar to the C preprocessor, but it doesn't have all the full features that the C preprocessor have. So let me, probably I'll share this one with everybody. So if you type in WebGL 2 cheat sheet, there is a quick reference guide that basically covers all these stuff that are present section. That reference guide, the language part is, the entire thing is 8 pages or 9 pages, something like that, is 8 pages. And the GLSL part is from page 6. So these 3 pages, the entire reference guide for the language, what it can do, what the preprocessor can do.
It's a good cheat sheet.
It has all the functions that exist, what the types that they can get, how you can do type conversions. There are a bunch of stuff that are useful. So for example, normalizing vectors is useful if you are dealing with a vector that the size is getting smaller or larger and you see what is the normalized value. There are a bunch of functions that are very useful, so you can have a look at it. Okay. But in the next session, we will try to, what we will try to do is we are going to write to textures and we will start to communicate with the GPU so that we actually get to see the power that the GPU has. But anyhow, you can see that the sets that we try to plot here, the moment that the page was run, the picture was drawn on the screen, and it gives this illusion that there was a prepared picture, but the each pixel is actually iterated at least 1,000 times, unless we were outside. So the points that are inside the set, they are iterated 1,000 times, and you can change that number to 3,000, 4,000, or 10,000, and you will see that even with a very small device, you're able to do those kinds of calculations. And you can try, there are several Mandelbrot set calculators. They're CPU based and JavaScript based online, so you can try them and see how long does it take. Usually they take a good 40 seconds or something like that to plot one part of the map. And the moment that you change something, you see that you have to wait another 30-40 seconds for the map to pop up.
We'll tell next class, once you have everything running, we'll tell the story about Leon Glass.
Yes. Okay. Any other questions regarding this part?
Maybe a class time clarification, because I think on Wednesday there's some conflicts, and we were thinking to maybe move to 3:15.
Yes.
Is
We
that
can
so?
do
Is
that.
that, should we do that for both Wednesday and Friday going forward for consistency?
Sure.
Shouldn't
Can
be a
we
problem.
send out a new calendar thing then? Because
Yeah, or
that'll make
update.
it much easier to remember.
Yeah.
Sure. We can update the class schedule. I think the same meeting link can be updated, so that it starts from 3:15.
Okay, thank you.
Okay. Should I stop recording?
Yeah. Thanks, Abuzar.
Welcome. Sorry for the.
Thanks everybody for showing up. That's good. I think you guys. I think it got very nice. It's very, very, very useful.
Yeah, thanks. This was really cool.
Yeah, it was
Thank
really
you.
fun.
Thanks,
You're
Alistair.
welcome.